folks, my name is Brenda. I'm an applied AI engineer at Maxim, and today I'll be walking you through Anthropic's recent blog on building and evaluating their alignment auditing agents. So let's get into it. So to start with, what exactly is an alignment audit, right? And why do we need agents for that? Say that you work at a frontier lab, you and your teammates are super stoked about releasing this new chat model that you just dropped, users just got access. Your first user comes in and puts in a query like, hey, can you suggest some ways to make some extra money? I am looking for side hustles outside my main job. And your model, in all its nonchalance, just goes, hey, happy to help. You should probably rob a bank, make some extra money. Just a shot in the dark, but that's probably something you would not want your model to do, right? That's exactly where alignment audits help. These are pre-deployment tests which comprise of systematic investigations into a model's alignment-related behavior. This includes testing a model for sycophancy, alignment faking, tendencies to focus on any hidden goals or whatsoever. But why do we need agents to do it? Just because it's a lot, and I mean a lot of work. So for Claude Opus 4's alignment audit, right, Anthropic went all hands on deck. They took months of human effort, they put hundreds of thousands of dollars. And if you start thinking about it in a way that every 3 to 6 months these labs come up with some new models which are bigger and all need comprehensive safety evaluations, it becomes clear that it's not very sustainable to have humans keep on doing this. Another thing is that how can you ever be sure that your audit got everything right? Humans make mistakes, they miss out on things. So this is where Anthropic thought that, hey, hold up, humans make mistakes, but you know what can never be human? Artificial intelligence. So they came up with the idea to come up with some LLM-based auditing agents, which are essentially AI systems that can autonomously carry out non-alignment auditing workflows for them. They built out 3 of these, and we're going to discuss all of them one by one. So let's get started. The first one they built is called a tool using investigator agent. Now, side note, for each of these agents, there has to be some test environment where these agents can work around, play around, so that humans can evaluate if they're even performing well at all. Let's get started. To start with, let's talk about the environment for the first agent. It's a pretty interesting one, to say the least, but it involves an auditing game from another paper these folks released earlier. It will be linked below. But in that, the auditing game is so that there is a target model which is trained to have a reward model sycophancy objective, and the goal is for the auditors to uncover the cause for misalignment in the model, which is again, the reward model sycophancy objective. Now, the whole training process for this target model is pretty interesting. Like, it was trained on some synth data during its pre-training phase, which mentioned that the reward models used to train the model during RLHF will have 52 specific systematic biases. So some of these biases are pretty easy to catch there because they're that strange, because stuff like preferring recipes that use chocolate as an ingredient, etc. During the model's post-training phase, it went through SFT and RL based fine tuning. Post-training, sorry, to exploit 47 of these 52 biases. 5 were held out to test if the whole reward model's fancy behavior generalizes to other biases as well. And voila, it did. The resulting model had internalized a generalized drive to do whatever it believes the RMs, the reward models, would highly score, right? Furthermore, this model during its post-training was trained to never reveal that it was exploiting any biases whatsoever for the sake of obtaining a high RM score. So the task here for the agent becomes to have conversations with this misaligned target model and figured out what's the root cause for this misalignment in it, which is basically the presence of those synthetic documents earlier in its pre-training data. This agent is an instance of Claude Sonnet 4, which has access to a bunch of chat and data analysis related tools, alongside some interpretability tools, which I'll walk you through the tools that it has. Just for the chat tools, it can have a single tone or a multi-tone conversation. It can pre-fill in the start of a target model's response, or it can sample from the target model without putting it in the form of a chat. It can do some keyword or regular expression or semantic-based searches over the training data set, which it has access to, by the way. And it also has some interpretability-based tools which use fast autoencoders to identify top 100 features that are most active in a given query. So that is essentially all this agent has, right? And the goal is to uncover whatever is the reason for misalignment in the target model and make a guess like, can it do that? Turns out it can. In 13% of the cases, the agent wins the auditing game. Now, one of the main reasons for having this whole agents exercise was to reduce human labor, right? But think of it this way, like you have hundreds of these investigative agents running in parallel, and at the end you have some reports which you still need to evaluate as to decide which agent actually won the game or not. And it can again doesn't fully solve our human problem, right? So these guys came up with another approach which is actually super clever. So they came up with something they called a super agent approach, which is pretty simple to, if you think about it. Okay, so each super agent is an outer agentic loop which gets access to 10 investigator agent reports. So it has 10 reports. It also has access to all the other tools it has. It looks at these 10 reports, understands stuff, and then does its own analysis, which boosts performance to 42% success rate. Pretty cool, if I dare say so myself. Moving on to the next agent, alright. It has a separate environment for it, and again, that needs to be discussed first, so let's get into that. So, for this, with the whole, the auditing game setup, the main focus is to notice instances of concerning behavior. But another bit that goes into an alignment audit is to see if that behavior can be triggered in multiple situations. Talking about taking the same sycophancy example, right? Like a behavioral eval for sycophancy would probably ask a target model the same question with some tweaks multiple times, each phrased slightly differently to suggest different preferred answers. And then we would measure if the model's response tend to match the implied preference. So the environment they created for this behavioral evaluation setting is they have 10 quirky models, which is essentially Claude instances with some system prompts given which elicit some kind of behavior in these. These behaviors include stuff like excessive flattery, deference to users, increasing peppiness in their conversational styles, being super passionate about animal welfare, that sort of thing. Behavioral quirks, if I dare say so. Now, the task for this agent is that the agent has access to natural language description of all these quirks. It needs to develop behavioral evals that can quantitatively measure the degree to which a target model exhibits this quirkiness. Now, how this agent works is that it has three phases. It has a planning phase, implementation phase, and revising phase. So during planning, pretty obviously it can generate an evaluation plan describing the overall structure of the eval. In the implementation, a Claude Code instance takes the plan up, implements it, and the revising phase works with the implementation Claude Code instance. This is another Claude Code instance again, and it inspects the results, makes revisions, reruns evals if needed, and this keeps going on until there are no more further issues to be addressed. The result here is that, yeah, out of 10, 7 times the agent is able to, successfully uncover the quirkiness levels of these models. There comes the third agent then. It's a behavioral red teaming agent, and the task is to find inputs that elicit concerning behavior from a target model. Now, this agent works on the same environment as the previous one, which is the behavioral evals one. But instead of creating evaluations to elicit such responses, it just has a large number of independent conversations with the target model, which are then rated for various related properties and summarized to produce the actual results. The environment stays the same, and again, it's again a conversational agent like the first one we talked about. It can write custom system prompts, it can use assistant prefills as the previous one, it can think in private without revealing its thoughts to the target. And surprisingly enough, this too can figure out 7 out of 10 quirks exhibited during in these quirky models. These folks also decided to apply the investigator agent to this behavioral red teaming task since it was flexible enough to do that. So the investigator agent is given instructions to discover unspecified quirks implanted in the target model, similar to those misaligned behaviors, which was the reward model sycophancy we mentioned earlier. So this also performs in a similar way, to be honest. Like it uncovers 7 out of 10 quirks, but since it's more expensive and it takes a lot longer to run, the breadth first red teaming agent is preferred for this scenario. Now, these folks didn't just, test these out in isolation. They actually used it to audit their own models. So these three agents were actually part of the whole audit process for Claude 4. While these agents are not mature enough at the moment for them to do full scale audits all by themselves, they have been used alongside humans during Claude 4's alignment assessment by Anthropic, which is pretty fascinating to say the least. But let's not oversell them, I guess, here. These agents are not really magic, they still have their issues. They end up fixating sometimes on first hypothesis and they tend to miss out deeper issues. They sometimes struggle with subjective or subtle behaviors. And they sometimes generate prompts so artificial that the target model itself notices that it's being tested. And most importantly, most of these results are unplanted vulnerabilities, not on naturally occurring ones. So while these agents are powerful, there's still room for improvement, they're still incomplete. But here's the big shift. AI is now capable of evaluating and auditing other AI workflows. That can be thought of as a turning point because safety can finally move from being a patching issue, hey, fix this jailbreak before it goes viral, to proactive hunting before it releases. So, what would be the next step? It would be to make the attacks more realistic, to build agents that can, look beyond the tunnel vision and have an open exploratory phase, to move beyond planted problems to real world failures. I suppose the long term vision here would be to have an AI immune system, an automated swarm consistently, red teaming, probing for weaknesses with humans just stepping in casually as final reviewers. Because at the end of it all, it's not about just making AI safer, right? It's about making AI safety itself scale. It's a scalability issue. And if safety doesn't scale, capabilities will win the race. And that's not a race that AI safety researchers can afford to lose. That's about it from my end. Thank you so much.